Hello everyone, myself Snehal Shinde, lecturer in Praveen Patil College of Diploma Engineering and Technology from Electrical Department. Subject is Elements of Electronics. Subject code is 22213. Unit 1 Semiconductor Diode. So we have started Unit 1 Semiconductor Diode. In previous lecture we have seen semiconductor, then intrinsic semiconductor, what is extrinsic semiconductor, then donor impurities, acceptor impurities. Now we will study the extrinsic semiconductors are of two types. First is the p-type semiconductor and second is the n-type semiconductor. So now we will see what is p-type semiconductor. So the p-type semiconductor, it is formed when a trivalent impurity is added to a pure semiconductor in a small amount, and as a result a large number of holes are created in it. A large numbers of holes are provided in the semiconductor material by the addition of trivalent impurities like gallium and indium. So a p-type semiconductor are formed by doping a pure germanium or silicon crystal with the trivalent impurities atoms. The materials having 3 valence electrons per atom are known as a trivalent impurities. And the example of the trivalent impurities are boron, gallium and indium. The effect of adding one of this element, so it will become p-type semiconductor. Such type of impurities which produce p-type semiconductor are known as an acceptor impurities because each atom of them create one hole which can accept one electron. Now we will see conduction through the p-type semiconductor. In a p-type semiconductor, a large numbers of holes are created by the trivalent impurity. So when a potential difference is applied across this type of semiconductor as shown in the figure. So in figure we have taken the p-type of semiconductor and we have connected a battery source to it. You can see positive and negative to a p-type electron. When an external DC source is applied across a p-type material, the holes moves in the valence band. The movement of holes is towards the negative terminal of the supply. The free electrons move towards the positive terminal of the battery. The holes are available in the valence band are directed towards the negative terminal as the current flow through the crystal is by holes which are carriers of positive charge. Therefore, this type of conductivity is known as a positive or p-type conductivity. In a p-type conductivity, the valence electrons move from one covalent to another. The conductivity of an n-type semiconductor is nearly double to that of the p-type semiconductor. The electrons available in the conduction band of the n-type semiconductor are much more movable than holes available in the valence band in a p-type semiconductor, even at room temperature, the electron-hole pairs are formed. These free electrons, which are available in minute quantity, also carry a little amount of current in the p-type semiconductor. So this was a conduction through a p-type semiconductor. N-type semiconductor. The N-type semiconductor is formed by adding a small amount of pentavalent impurity to the pure silicon or germanium material, which acts as a base material. The pentavalent element is one which has 5 valence electrons. The example of pentavalent impurity are antimony, arsenic, phosphorus. So, when a small amount of pentavalent impurity is added to a pure semiconductor, providing a large number of free electrons in it, the extrinsic semiconductor therefore formed is known as N-type semiconductor. The conduction in the N-type semiconductor is because of the free electrons denoted by the pentavalent impurity atoms. The addition of pentavalent impurities such as arsenic and antimony provides a large number of free electrons in the semiconductor crystal. Such impurities, which produce N-type semiconductors, are known as the donor impurities. Now we will see conduction through the N-type semiconductor. In this figure, we have taken the N-type semiconductor and we have connected a battery source, positive, negative, to the N-type semiconductor. In the N-type semiconductor, a large number of free electrons are available in the conduction band, which are donated by the impurity atoms. When a potential difference is applied across this type of semiconductor, the free electrons are directed towards the positive terminal of the battery. It carries an electric current. As the flow of the current through the crystal is constituted by free electrons, which are carriers of the negative charge, therefore, this type of conductivity is known as negative or N-type conductivity. The electron-hole pairs are formed at room temperature. These holes, which are available in small quantity in the valence band, also consist of a small amount of current. For practical purpose, this current is neglected. Now the difference between the p-type semiconductor and the n-type semiconductor is group of doping element. In the p-type semiconductor, third group element is added as a doping element to form the p-type semiconductor, and in the n-type semiconductor, fifth group element is added as a doping element to form the n-type semiconductor. Nature of doping element in the p-type semiconductor is impurity added creates vacancy of electrons, holes known as the acceptor atom in the n-type semiconductor. Impurity added provides extra electrons and it is known as a donor atom. Type of impurity added in the p-type semiconductor is trivalent impurity, like aluminum, gallium, indium are added. In the n-type semiconductor, pentavalent impurity like phosphorus, As, Sb, Bi are added. Majority carriers in the p-type semiconductors are holes are the majority carriers, and in the n-type semiconductor, electrons are the majority carriers. Now minority carriers. In the p-type semiconductor, electrons are the minority carriers, and in the n-type semiconductor, holes are the minority carriers. So this majority and minority carrier in the p-type material, a large number of holes are present in a p-type semiconductor along with a small number of generated electrons. Hence the conduction largely takes place due to the holes. Therefore, holes are called as the majority carriers and the electrons are the minority carriers for a p-type semiconductor. And majority and minority carriers in the n-type material, a large number of free electrons are present along with a small number of thermally generated holes in an n-type semiconductor. So the conduction largely takes place due to the free electrons. Therefore, the free electrons are called as majority carriers and holes are known as a minority carriers. And the donor impurities, so each pentavalent impurity atom generates a free electrons as we have discussed earlier. So the number of free electrons will be equal to the number of impurity atoms added, as each impurity atom donates one free electron. The pentavalent impurities are known as the donor impurities. So in this lecture we have studied p-type semiconductor, conduction through the p-type semiconductor, n-type semiconductor and the conduction through the n-type semiconductor, and detailed version of the difference between p-type semiconductor and the n-type semiconductor. What is added in the p-type semiconductor and what is added in the n-type semiconductor. The adding of the impurity, it is known as a doping. This process is known as a doping. Adding of the impurity to the pure form of the semiconductor, that is the intrinsic semiconductor. As we have discussed, semiconductor are of two types, intrinsic semiconductor and extrinsic semiconductor. This p-type semiconductor and n-type semiconductor comes under the extrinsic semiconductor, which is formed by adding the impurities. If we add the trivalent impurity, it will become the p-type semiconductor, and if we add pentavalent impurity, it will become the n-type semiconductor. So this is the detailed version of the p-type semiconductor and n-type semiconductor. Thank you.